So simplify the following expression. So this expression is cos 90 plus x, sine x minus 180, negative cos squared 180 minus x, all over cos negative 2x. All this is added to sine squared x. Okay. To answer this, the first thing I'm going to do is draw the quadrant. Now I'm drawing the quadrant to help me remember all the identities necessary to calculate this question, right? This is all, here's positive, that's sine, that's tan, that's cos. Now for the positive quadrant, we consider this theta, this is 180 minus theta, this is 180 plus theta, this is 360 minus theta. Whenever you have the negative quadrant, it looks like this. This is negative theta, this is theta minus 180, this is negative theta, negative 180, and this here is theta minus 360. For cofactors or cofunctions, this here is 90 minus theta, and this here is 90 plus theta, right? So we can use each and every one of these identities to help us reduce our expression, okay? So the first one here says cos 90 plus x. Now this is cofactors, and 90 plus theta is in the second quadrant, right? And 90 plus theta in the second quadrant would mean that this would have an overall negative sign, right? However, with cofactors, cos always changes to sine, so this here would actually be negative sine x times. Now we have x minus 180 is part of the negative quadrant here, which is theta minus 180. It is negative for this, so since it is sine, and sine is negative in the third quadrant, this can be written as negative sine x. We have minus. Then we look through this one here. This is 180 minus x, but there is a squared here. So it's best to look at this, that you rewrite this expression as cos, and the squared is outside here. Now if the squared is outside like this, whatever I have inside the bracket, I can square it after I'm done. Now 180 minus x is in the second quadrant, so this here could be written as negative cos x squared, okay? Now all this is over. Now this is cos negative 2x. Negative 2x is in the fourth quadrant because that's negative theta, so that can just, and cos is positive in the fourth quadrant, this can be written as cos 2x. And you have plus sine squared x, okay? So simplifying a little bit further, negative sine x times negative sine x will give you positive sine squared x, right? So this here can be written as sine squared x, okay, minus. And this is negative cos x. When you square it, it gives you positive cos squared x, right? So because there's also a negative here, this here is just going to be cos squared x. Yeah, this here is over. Now cos 2x is a double angle identity for cos. We can write this as cos squared x minus sine squared x, right? And all this is that there. Okay. Now the next thing I'm going to do here is I notice I can cancel out the numerator and denominator, but I can only cancel it if I rewrite the denominator. So what I mean by that is that this can be rewritten like this. Bringing out a negative makes the numerator and the denominator the same. You have sine squared x minus cos squared x, sine squared x minus cos squared x. Now this is plus. So in that case here, this whole thing will cancel that whole thing. So you're just left with negative 1 plus sine squared x, right? Which, as you know, is the same thing as saying sine squared x minus 1. And that's also an identity. And this identity gives you cos squared x. And that's the simplification of this expression. That's it.